let me summarize the work on vehicles that drive themselves, work going on at Carnegie Mellon University, sponsored by General Motors, the National Science Foundation, and the US Department of Transportation. Why build self-driving vehicles? Motivation is threefold. First and foremost, 1.2 million people die every year on a global basis due to automotive accidents. 1.2 million people. Turns out that more than 90% of these accidents happen due to human error. Humans are distracted for any number of reasons. If instead of humans being in control of the vehicle, if computers are in control, they are not prone to the human frailties of distractions, emotions, and such physical fatigue. Vehicles can continue to be more reliable, and therefore we can actually reduce the number of accidents, injuries, and fatalities. So that is the driving promise of self-driving vehicles. Number two, traffic delays are expensive. The average American commutes for about 52 minutes per day to and from work with a single person in the car. Right? 52 minutes per work day just wasted in commuting back and forth. If instead computers are driving the car, people to and from work, those become productive times, and therefore could actually have a measurable impact on global economic productivity. Number three, there are people who are disabled, and there are people who actually are elderly, lose their cognitive skills to the point that they actually lose their driving privileges. At that point in time, particularly in countries like the US, it's typically elderly ladies. They're basically stuck at home. They actually lose their mobility, and therefore their independence, and therefore their quality of life actually drops dramatically. If instead vehicles are able to basically drive themselves and take these disabled or elderly people to and from different points of interest, meet with friends and relatives and such, or even go shopping, they regain their mobility, their independence, and their quality of life can go up dramatically. So these are three causes that basically drive our passion to basically work on self-driving vehicles. Translating that to a vision of what can happen, these are pictures of accidents that happen on the roads. If you actually use your favorite search engine, look for automotive accidents, you will literally see millions of images of such accidents. We just take them to be a part of modern life. This is the price that we pay for modern civilization. Right? It's just taken for granted. You buy insurance and you live with it. Right? So it is a fact of modern life, or should it be? So we really want to basically have a grand challenge that we set for ourselves is that can we use technologies, reliable technologies, to basically make our automotive fatalities just go away, be completely eliminated. Zero automotive fatalities is what we are aiming for. We may never ever reach this number zero, but as long as 1.2 million automotive deaths globally every year go down to 120,000, 12,000, maybe to 1,200, society at large will be a huge winner. So basically what this means is that there will be not just fatalities, there will be much fewer accidents and injuries as well, and then there will also be higher throughput or at least productivity during commute times and such. We also expect that the infrastructure that we currently have can become smarter. For example, traffic lights and road signs can basically broadcast their status, which can be received under adverse weather conditions and lighting conditions, and therefore the number of accidents, injuries, and fatalities can also go down. So this vehicle that you see on the screen is a vehicle that was fielded by Carnegie Mellon University, a team called Tartan Racing, Tartan being the mascot of Carnegie Mellon, was fielded in the so-called 2007 DARPA Urban Challenge, where DARPA is a US defense agency standing for Defense Advanced Research Projects Agency. This is the same agency that actually created a network called the ARPANET, which we know and love as the internet today. Right? Very forward-looking agency, and they basically are the ones who actually launched the GPS satellite system as well. So this agency actually had a competition in 2007 where the objective was for vehicles without anybody in them to drive for 60 miles, about 60 miles, in fewer than 6 hours in an urban-like setting with other manually driven vehicles and autonomous vehicles with nobody in them driving around, and all of them actually had to follow the rules of the road. was a very impressive competition. Started with 125 participants, of which about 36 were actually invited to the final qualifying event on site, and then that was trimmed down to 11 participants, and so 11 teams actually participated on the final competition day. I am proud to say that our car here named Boss actually won the competition, $2 million prize, about more than 20 minutes ahead of the next vehicle that completed the race. So this was a watershed moment in the evolution of autonomous vehicles. It basically demonstrated that vehicles without anybody in them can deal with traffic, can actually obey traffic rules, and then take care of situations that actually arise unexpectedly because a whole bunch of things going on at any given time, and then deal with different kinds of road conditions, unpaved roads, paved roads, very bright sunny conditions, and so on. So it basically was a seminal moment. So that actually happened in 2007. And it turned out that, as you can see, the vehicle actually had a whole bunch of so-called sensors. These sensors included multiple cameras, radars, and laser scanners, also called as LiDARs. And so they were outfitted all over the vehicle, equipped in the vehicle. Some of them were used for detecting the presence of roads, some of them for detecting obstacles, some for tracking vehicles, and so on. So it turned out that that competition, impressive as it was, did not include any pedestrians. The joke was that nobody volunteered. There were no bicyclists. There were no traffic lights to worry about. Because it was only a finite race for about 5-6 hours, you really did not have to worry about things failing, things going wrong. For example, you did not worry about sensors failing, actuators failing, or processors failing. And by rule within the competition, you could not communicate from the vehicle to the outside or from the outside to the vehicle by rule. So no hanky-panky allowed. And there were no cost limitations. I guess I should say that we had a substantial number of sponsors and donors, as you could see on the vehicle plastered with stickers and so on. We could afford a lot of money, and therefore we could actually throw in basically the kitchen sink at it and have all sorts of capabilities inside the car. And then this was actually, the competition was actually held in a desert, very sunny, so did not have to worry about bad weather conditions, rain, snow, or fog. It was during bright sunlight, so it was did not have to worry about nighttime operations. And traffic, even though the competition when it started out was relatively, the traffic was heavy, but over time vehicles basically, I guess, ran into each other or ran into buildings, got disqualified, and the traffic on the race course actually thinned out fairly quickly. And then you could make this assumption that GPS was always available, because you were basically in a desert, wide open blue sky, so you could always see multiple GPS satellites in the sky. And then you could even use actually military grade GPS, which gives you very high precision locality information. And we could actually, for example, go and buy high resolution maps of the desert way beforehand, and which is actually very helpful for making appropriate decisions. And then for safety reasons, because there were actually humans driving some vehicles on the race course, there was a maximum speed of 30 miles per hour imposed by DARPA. So then, given that we won the competition, it became very clear that this technology is no longer science fiction. What used to be just imagination in people's fancies actually could turn out to be very viable, and actually could be a lot more in the near future than far away into the future. So then basically companies like General Motors basically became our sponsor. They already were a big partner on our team. They basically sponsored a lab, and we basically started investing a lot more in this technology to basically make it viable, affordable, and reliable. But so basically we understood there are still a bunch of challenges that remain. The first set of challenges, I refer to them as exogenous challenges, meaning coming from outside the vehicle. This has to deal with the complexities and the uncertainties of the real world that the real world throws at you. Things like bad weather conditions, poor lighting conditions, and horrendous road conditions. Right? Many of us are accustomed to these things on a regular basis. Construction zones pop up on a regular basis. Accidents can happen. Information in your maps can actually be obsolete, and you could lose GPS in a tunnel in an urban area where you have skyscrapers pretty much all around you, and you really do not get to see the sky. So that's a big set of challenges. A second set of challenges called, I refer to them as endogenous, meaning coming from within the vehicle, where the vehicle actually has sensors, processors, communication networks, and actuators to basically steer the vehicle, apply the brakes and gas pedals. Those things can fail as well. But it turns out that because they are actually within the vehicle, they are within our control, it's much easier to actually come up with the solutions. Exogenous, completely outside our control. And then the one big question that one has to keep in mind is that no matter how you slice this technology, it is a very complex system. Lots and lots of things actually trying to work together, meaning and trying to deal with the uncertainties of the real world where things are completely outside your control. And the question becomes, how do you know that this complex system does the right thing, is always safe at all times? So that's actually a big challenge that needs to be looked at. And then that DARPA urban challenge did not allow interaction between vehicles or communication among vehicles. But in the real world, we do interact. Mostly for negative purposes maybe, but occasionally for positive reasons as well, by letting somebody come in when they need to actually get in and we actually yield to them. So there will be interactions between entities as well. So vehicles will be capable of talking to other vehicles. They will be able to talk to traffic lights. They'll be able to talk to traffic signs, for example. So we need to bring in that cooperative aspect into the picture as well. This technology, as I said before, has to be absolutely reliable and safe. And cost questions come up, maintainability comes up. And the other thing to keep in mind is that we will never ever see a point in time where we say, hey, today we all drive manually, tomorrow all of us are using autonomous vehicles. That is never going to happen. There will be a hybrid of manually driven vehicles for a long time, and over time more and more autonomous vehicles, self-driving vehicles come to the picture, and eventually we'll be moving towards a full spectrum of self-driving vehicles. So we have to worry about this incremental deployment where humans and computers have to interact on a regular basis. And so we expect basically that adoption of autonomous vehicles also actually happen in a very natural, incremental and organic fashion. Last but not the least, I guess there are technological reasons, of course, that all of us have to worry about, which I have talked about. It turns out there are other challenges as well. There are legal issues that need to be dealt with, regulatory aspects that need to be handled as well. Right? So the first time an autonomous vehicle is actually involved in an accident, the question is, who is liable? Is it the driver or the non-driver in the car? Is it the car maker? Is it the passengers in the car? Or is it basically the local government which did not maintain the roads correctly? Basically, for example, fading lane markers and such. Huge questions. And rather from a regulatory perspective, I guess for even self-driving vehicles to be allowed to drive on the roads, you need to basically have a driver's license. What does it mean to basically give a driver's license to a vehicle that drives itself? So a whole bunch of regulatory issues have to be ironed out as well. And then clearly different countries will likely take different leadership roles, prominent roles in trying to make this happen. So that right now as we speak, there's a global competition among countries to basically take the leadership in trying to push these aspects forward, as among the states of the US as well. Different states are basically trying to compete because they can attract talent and employment and jobs to their respective states. So let me now take a step back and look at the complexities of the real world. So basically here are some signs and markers of different kinds that we see on the road, potholes of different kinds, and then various road signs. So it turns out that we as humans, a road sign is a road sign. Right? I guess we are either literate or illiterate. We understand what's going on, and we deal with things as we go. Right? It just becomes part of our second nature, maybe even third nature. We don't even think about it. We just actually react to them on the fly. And here is basically, I guess, there is wild animals on the road that you can find. You can actually see, for example, kids, and then you basically have tourists standing right in front of the road on a lane marker taking pictures and so on. Happens in many tourist spots. A person on a wheelchair, school guards basically letting kids go through and so on. So the number of scenarios, kind of unexpected scenarios, turns out to be a very long list. We as humans have lived as part of society for a long time. Many adults have been driving for a long time. We don't think about it. We don't give it second thought. We just do it. Right? But computers have to be taught to do this. So here are 3 videos that actually show a bicyclist riding around our autonomous vehicle, and we actually detecting them. So on the top left screen, you basically see a bicyclist basically going perpendicular to the car, right? So I guess cutting across, and then you basically see a bicyclist on the top right basically driving in the direction of the car, and on the bottom left you will see multiple bicyclists driving in front of the car. Right? So very common actually many East Asian countries, for example. So you need to be able to deal with all these combinations of things, 2-wheelers and 3-wheelers and multi-wheelers of all kinds happening. And meanwhile, you see on the top right different instantiations of traffic lights. To a human being, a traffic light is a traffic light. It has a red, that's a yellow, maybe a green, and we really don't think about it's vertically oriented or horizontally oriented, how they are actually laid out. We don't have to think about it. We just know. For a computer, everything has to be taught, right? So that because if you go to different countries, actually they're laid out differently and so on. All of that takes time and energy, right? Because you need to actually write algorithms actually which work under many different scenarios, and some of the traffic lights can be hidden from view because of a very tall truck right in front of the car. So lots and lots of complex scenarios have to be dealt with. And I guess the other thing I would note is the following. This was the vehicle that I showed you before, the vehicle that was nicknamed Boss, has all these sensors hanging off of it. To an engineer like me, it's a beauty. Right? So look at all that cool stuff hanging out of there, and we think about, hey, I can do so much more with all these sensors on the car. But to the normal person, or to the non-technical person, what the heck is that? It's a monstrosity. Right? Nobody would pay how much ever it costs to basically have that sitting in their garage, right? And then meanwhile, for example, this is a typical version that Google has been deploying for some number of years, with a spinning sensor. It turns out it's actually a bunch of laser beams that are actually spinning on the roof of the car, right? There are 3 issues with that. One is that it does not make the vehicle look aesthetically pleasing. Number 2, it actually is spinning at about 10 rotations per second on the roof of the car. And when your car is driving on a highway at 65 miles per hour, about 110 kilometers per hour, here is something that is spinning at high speed, it is not going to last very long. And then if you have to replace it every couple of years, this costs only about $55,000 US per piece. So it's way too expensive, as cannot be affordable. So what we basically set ourselves for is that basically the goal to basically make the vehicle look very normal, aesthetically pleasing, so that normal people, non-technical people can say, hey, I can relate to this vehicle. If it can drive me from point A to point B without my involvement, I could see myself enjoying that process. So that's what we did with this car. We basically got rid of that sensor on the roof of the car, and we basically ended up with that. So it looks very normal on the outside. It does have multiple radars, cameras, and laser scanners all around the vehicle, except they are actually hidden in the body, behind the bumpers, behind the windshields and the windows and such, and you would not know to look for them unless you know that they are actually there. And if you look at the passenger space, we also, on the inside, we made the vehicle look very clean as well. It looks no different from you going to an airport, renting a car, picking up the keys. You know exactly what to do. You start the car, you start driving to a destination. You could do exactly the same thing in this car. Drives just like a normal manually driven vehicle, except that if you see this button out there behind the stick shift, if you consciously rotate the switch and pull it upwards, the vehicle goes into autonomous mode, starts driving itself. So in the near future, for legal reasons and for regulatory reasons, we must have a safety driver in the driver's seat paying attention to the process while the vehicle is driving itself. And then if the human is uncomfortable at any point in time, he or she has to just reflexively push the switch down, and the vehicle will give back complete control back to the driver. So the driver is under complete control at any given point in time just by simply pushing a button. And it is just basically a back shot, and what you see on the screen here is this is actually a stock screen that we actually added capabilities to in the car. It basically shows what the vehicle sees using its sensors. So this is the way the vehicle's computers actually see the world in which the vehicle is driving around. On the top left of the screen, you basically see a video of the vehicle being sent commands by the computers. There are multiple computers in the vehicle that basically lets it steer the steering wheel and then apply the brake pedal and the gas pedal, the accelerator pedal. That's what you see on the top left. On the top right, you basically see a sequence of various events happening where if there's a road being blocked, the vehicle actually detects that and automatically stops, and can basically then once the road blockage is removed, it actually will continue to go forward. On the bottom left, you basically saw, you probably missed that, it was actually showing a case where there were two manually driven vehicles and our self-driving vehicle coming to a four-way stop intersection, and our car came in second, and a manually driven car came first, and then another vehicle actually came in third. Our car knew that it was its turn. It was its second turn to basically take the intersection, which actually it does normally. And then you also saw pedestrians and bicyclists being detected. The bottom right screen, you would see a video where actually as the vehicle is driving along the road, it notices some construction signs, work zone signs, and therefore actually steers away from the cones that actually delineate the construction space, and then it actually announces that actually it's a construction zone. It is able to avoid that. It also realizes when the construction zone ends and it resumes its normal driving behavior. So the vehicle is smart in many ways. So this is actually a ride that the vehicle actually drove itself from a town outside Pittsburgh all the way to the Pittsburgh International Airport, a 33-mile long journey through a slow-moving park, suburban highway, and then actually took an entry ramp to an interstate highway, I-79 South it turns out, and then takes an exit ramp from that highway, which becomes an entry ramp to a different highway, which turns out to be I-376 West, which actually takes the vehicle to the Pittsburgh International Airport. It just changed lanes out there, all of it completely autonomously. And the gentleman on the right is basically Bill Schuster, who is the chairman of the U.S. House Transportation Infrastructure Committee. It's one of the strongest committees in the most powerful committees in the U.S. Congress and in Washington, D.C., the federal government of the U.S. So let's listen in.
It was excellent. It's amazing. Did it without even a hitch.
So 33 miles completely autonomous. Chairman Bill Schuster was very impressed. Actually, he was so impressed that he actually asked us to basically bring the car to Washington, D.C. so that his colleagues on his committee and a related committee named Science and Technology Committee of the U.S. House of Representatives could actually take a ride in the car, which we did in middle of 2014, and about 20 legislators from the U.S. House actually took a ride in the car as well. So what we have shown is that if vehicles can drive themselves, there is huge societal impact, positive impact that can be made, number one. Number two, the technology has been progressing very rapidly, particularly in the past few years. So it's actually getting closer and closer. But I do need to caution that do not expect vehicles to drive themselves from any point A to any point B anytime in the near future. What the vehicles will be able to do is basically drive themselves on particular segments of your journey. For example, on the highway, we'll be able to, over time, be able to change lanes on the highway. It'll be able to drive itself in a traffic jam, be able to actually park itself in a parking garage or open parking lot. So those things will be automated first, and then as those technologies are known to be reliable, affordable, and acceptable to the consumers, and then more and more features actually become automated, and then that process keeps going, and one fine day, the last little bit of road segment that the vehicle was not driving will be driven by the car also. But that last step will actually be barely noticed, but because you've given up most of the control for quite some time anyway, and that will basically be about maybe about 15, 20 years away. Okay. So I thank you for the opportunity. I just end up with the comment that transportation is part of modern life, day-to-day life, and then this domain is basically very ripe for accepting this technology that we refer to as connected automation. Thank you for your time.
insurance, et cetera.